Good afternoon, everyone. This is BremSter, and today I'm coming to you with a puzzle that I've been trying to figure out how to record this one for a few months. This is a puzzle that was created by Maggie, who is my mother, and I, back in August, and we published this one to Logic Masters Germany, and there was a bit of positive feedback, and like every puzzle that I published to Logic Masters Germany, a bit of negative feedback. I'm not too worried about that. And I think this is one of the hardest puzzles that we've recorded. My testers came back saying that this was a really hard puzzle. We thought this was a really hard puzzle. Logic Masters Germany rated this one as 3 stars, which to my mind means that this is actually quite a tricky puzzle. And I was trying to figure out how I wanted to present this puzzle. I know some of the tricks for this puzzle, and I still think that this puzzle has some really nasty tricks in it, but I did want to present it to you all and let you decide for yourself how tricky you think this is. So this is Bleeding Edge by Maggie and BremSter, and we were about equal on the creation of this one, I think. And we tested this one over a couple of nights, coming up with different ways of refining it, putting things into the puzzle, and then how we would change the puzzle to make it work. This one took quite a while. This is probably the puzzle that took us the longest to create, then test, then change, then test. This one was probably, for the two of us, probably about 15 hours in the making. So, yeah. Let's just go into the puzzle, and you can let me know in the comments what you think of the puzzle, what you think the difficulty of the puzzle is, not just by time, but by the logic used and everything like that. I'm curious to see what the feedback will be, and whether you think 3 stars is appropriate, which would make it an average difficulty puzzle. Remember, the ratings are 1 to 5, so 3 stars would make this a mid-range difficulty puzzle for someone who is coming into the hobby. So, Bleeding Edge by Maggie and BremSter. So what do we have in this puzzle? We have normal Sudoku rules apply. So in every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. We have arrows. So digits on an arrow must sum to the digit placed in that arrow's circles. Digits may repeat on an arrow if allowed by other rules. So if those two were both 2, this could be a 4. That would be perfectly legal. The sum of those 3 goes here, the sum of those 3 goes here, the sum of those 2 goes here. German whispers. Adjacent digits on a green line must have a difference of at least 5. So these 2 digits will have a difference of at least 5, as will those 2, as will those 2, as will those 2. These cells, as you can see, are connected by green lines. I've done some placement on these, so it's very clear that, how the constraints work. The green line goes into this cell, but I wanted to make sure that the arrows and the lines were distinct. Purple lines. Digits placed on purple lines must be a non-repeating set of consecutive digits in any order. So what that means is, for example, this line might be 1, 2, 3. That might be possible. It can't be 1, 2, 4 because it can't be 1, 2, 4 isn't a consecutive set of digits. Basically, what goes onto the line must be non-repeating. I couldn't have 1, 1, 2, but if I was to take the digits off and sort them, they must be as a run of digits. So 3, 4, 5, that might be possible for this line. I don't remember. So they're the rules of the puzzle. As you can see, it's a... and if you're wondering the name of the puzzle, it's because there's this sort of fidget spinner type shape, and all 3 of these lines are German whisper, but this is the bleeding edge because it's got a pink edge rather than the green one. I'm going to restart the puzzle to restart my timer. Let's give this a shot. Now, I do remember a lot of the stuff we put in this because we tested this quite a few times. The first place to look is this central cell. Minimum of these would be 1, 2, and 3. So any 3-cell arrow where they all see each other, this would be 6, 7, 8, 9. Now this can't be 6 or 7 because if this was 6, these would be 1, 2, 3, but this would be 1, 2, 3, and there'd be 4 cells in this column that'd be 1, 2, 3, and you could do that on any of the arrows. So these would be all 1, 2, 3. It just doesn't work. Similar with 7. A 7, 3 arrow is 1, 2, 4, because I'd have to increase the 1, 2, 3 by 1. The only way to do that is increase the 3 to a 4. So all of those 4 cells would be 1, 2, 4, and I can't make 4 cells in one row, 1, 2, 4. So this can't be a 7. Now, it also can't be 8, but the question is why? Well, any 3-cell arrow that is 8 must have a 1 on it. So there would have to be a 1 on each of these arrows. And that doesn't work, because if I put a 1 in this box, then a 1 would be here. I couldn't repeat a 1 in the box. There'd be a 1 here, a 1 here, and a 1 here, and there'd be 2 1s in the column. So I couldn't put 1 in the box, because if the logic is symmetrical. If I put a 1 here, 1 would have to go here, here, and here, and I put 2 1s in column 6. It doesn't work. But if I don't put 1 in box 5, there's 1 here, 1 here, 1 here, and 1 here. And with all of those 1s looking into box 5, the only place I could put 1 in box 5 is slap bang in the middle. But I've already stated that the central cell is an 8 in order to cause those to all be 1s. It's a contradiction. It doesn't work. So the central cell is a 9. And we know that this has to be 9. Okay, so that's just the first obvious deduction. The next obvious deduction I want to talk about is German whisper lines. So along German whisper lines, the first thing is you can never put a 5 on a German whisper line. There's a whole bunch of stuff I'm going to talk about concepts, and if you're not having to worry about explaining concepts, there'll be things that are just much quicker for people who are solving. But you can never put a 5 on a German whisper line because of the 5 difference. In order to have a 5 difference, you're either adding or subtracting 5. So if you were to put a 5 on a German whisper line, to add 5, you're going to 10 or higher, doesn't work. To subtract 5, you're going 0 or lower, doesn't work. So every digit is either going to be below 5 or above 5. If it's below 5, the digit next to it can't also be below 5. The maximum difference is 3, so the next digit would be above 5. And if you've got a digit that is above 5, the next digit can't be above 5. It would have to be below 5, so the next digit would be below 5. So you're always going to alternate high, low, high, low, high, low as you go along a line. Now, let's look at these lines. Could those, because these alternate, those two are both the same high-low, because you're always, as I said, you're going to alternate. Every second digit along a line is going to be the same. Could these both be high? Now, let's talk about 3-cell arrows. And I, unfortunately, need to turn on my air conditioning. It's getting hot here. Let's talk about 3-cell arrows. Now, a 3-cell arrow that sums to 9, where all the digits see each other, there's only 3 possibilities. If I don't use a 1, it could be 2, 3, 4. The minimum digits sum to 9. So that's one possibility. If I do use a 1, if I make it 1, 2, then the next digit would need to be a 6 to make it work. If I don't use 1, 2, and I go with 1, 3, the next digit becomes a 5. So you've got 1, 3, 5. If I was to not use 1, 2 or 1, 3, I would end up with 1, 4, and I would need to use 1, 4, 4, which doesn't work. So the only possibilities are 1, 2, 6, 1, 3, 5, and 2, 3, 4. They're the only ways to make a 3-cell 9 arrow. Now, if you notice, every one of these has 2 low digits on it. 1, 2, 1, 3, and 2, 3. And a 4, 5, or 6. So that is an important concept to understand here. But the only high digit, the only digit above 5 that is in that set is 6. So if these were both above 5, those would both be 6s. But that doesn't work, because if this is a 6, these are 1, 2. If this is a 6, these are 1, 2, and all those 3 cells are from 1, 2. These can't be high digits, or those would all have to be from 1 and 2, and I can't put 1 and 2 into 3 cells in a row. Those are low digits. This is a high digit. So this is from 6, 7, 8, 9, but it can't be 9. So this is from 6, 7, 8. So these are from 1, 2, 3, 4, but in order for them to be 4, in order to have a digit that is 5 different, that would need to be 9. So those can't be 4. They're only from 1, 2, 3. Now in this puzzle, I'm only going to colour 1, 2, 3 blue, and I'm not going to colour high digits at all in a second. You will understand what I mean. These digits, can these be 6? No, because if these were 6, this would be a 1, 2, and this would be a 1, 2, and I'd have 3 1, 2s in column 6. It doesn't work. So these can't be high. These must be low. This must be a high digit. I'm going to get rid of the high digit in a moment. These are from 1, 2, 3, 4. This is from 6, 7, 8, 9, but it can't be 9, which means those can't be 4. Could these be high? And the answer is the same again, no. Because if these were 6, then this would be 1, 2, but these would be 1, 2 because 6, 1, 2, and I'd have 3 1, 2s in row 6. It doesn't work. So these are low digits. This is a high digit. So this is 6, 7, 8 because it can't be 9, which means these are 1, 2, 3. Now, I'm going to keep colouring the 1, 2, 3s, but there's my 2 1, 2, 3s on this arrow. So this must be 4, 5, 6. There's my 2 1, 2, 3s on that arrow. That must be 4, 5, 6. Now, getting into the concepts of how I'm going to solve this, I don't have a predefined path for this. I'm going to have to discover some stuff as I go. I don't have a solve path locked into my head. I wish I did. This puzzle is not that easy to me. Okay, but the next thing I want to talk about is these cells, and can those have the same digit in them? And the answer is no. These can't be the same digit, because if these were the same digit, I'd have a conflict. If these were the same digit, where would they go in the grid? Well, they couldn't, in box 5, they couldn't go into any of those cells, and they would have to go there. But if we think about this can't be 1, 2, 3. So this has to be 4, 5, or 6, but every arrow needs a 1, 2, 3 on it. 2, 1, 2, 1, 2, 3s. So this is the 1, 2, 3. So I can actually colour that as the low digit. So this is a 4, 5, 6. But if these were the same digit, they'd have to be a 6. Because I couldn't put, if these were the same digit and they were 7, this would have to be a 7 and this arrow would be a broken. So if these are the same digit, they'd have to be a 6. But if these were both 6, those both 2 digits would have to be a 1. If these 2 digits were the same, again, they would have to, in box 6, they'd have to go there. Box 5, they'd have to go there. So the only digit they could possibly be would be 6, which would make all 4 of those digits 1, and I've got 2 1s in box 5. It doesn't work. So these can't be the same digit either. So all of these are different digits. If these repeat, whichever ones are repeating has to go there, which means it's got a maximum of 6. And if either of these are 2 6s, then we've got 2 1s in this box and it's broken. Or 2 1s in this column and it's broken. Doesn't work. Now, this is the only bit I've kind of memorized. After this, I'm kind of a little bit stuck. I'm not 100% sure how I lock in the next progress. Now, and I know the next deduction is around this being 6. At least I think it is. And can that be a 6? Because if this is a 6, this is 1, 2, this becomes 3, which makes that 8. Now, an important thing to realize is because these are all different, whichever one is the 6 is going to take the 1 in box 5. So therefore, whichever one is the 7 has to take the 2, and whichever one is the 8 has to take the 3. So with these being, if this is a 6, this is a 1, 2, this is a 3, this is an 8. So this becomes a 7, this becomes a 2, this becomes the 6, and this becomes the 1. So if this is the 6, this is the 6. Now, if this is the 6, this is the 7. Right. And here's the problem. If this is the 6, this is the 8, 3. These are 1, 2. This is the 7. So because this is the 7 and the 3 is here, this becomes a 1, 2 pair, and that would need to be a 6. So let's try and follow that through. 6, 1, 2 makes that the 3. these become 1, 2, which means that has to be the 7, because whichever place the 3 goes here must take the 8. That's the 3, that's the 8. So this is a 6 or a 7. A 6 or a 7 here means that's a 1 or a 2. A 6 or a 7 here means that's a 1 or a 2. 1, 2 here means that's 6. So if that's the 6, that's a 6. This can't be a 6. So if that's not a 6, this must contain a 3. There is no way for this not to have a 3, because if this doesn't have a 3, this is 1, 2, 6. So there is no 3 here. 3 is in one of those two, and there's no 3 here. Okay. Now we can ask ourselves, where do these cells go in box 5? Because this can't contain yellow, red, or orange anymore. So yellow and red must go into those 2 cells. And this is 6, 7, or 8, and orange must go into one of those 2 cells. This is now a 6, 7, 8, 9 quadruple. Okay. Now, so these are all 1, 2, 3, 4, 5, but I'm not sure that helps me yet. Well, what does help me is because of this 1, 2, 3 and this 1, 2, 3, I can't put 1, 2, 3 into any of those cells. These become 1, 2, 3. So those are the 1, 2, 3s. If this is low, it's 1, 2, 3. It can't be 4, because if this was a 4, both of the digits on either side would need to be 9. So these become 6, 7, 8, 9. This can't be 6, or both of those would need to be 1, and it can't be 9 because that would break the arrow. So this is a 7 or an 8, which means this is a 1 or a 2, and the 1, 2 means this becomes an 8, 9. But now I've got a 1, 2, which means that's the 3. And I get another digit in the grid. Okay. Now, there is something interesting about 9s in this box. Where can I put 9? I can't put 9 in any of those, and I can't put 9 there. If I was to put 9 here, these would all become 6, 7, 8. Now, that may look okay, except because in order for the Renban to work, it'd be 9, 8, 7, 6. But these cells would all be 6, 7, 8, and that would be 9. So these would be 6, 7, 8, 9 in the box. But this has to be lower than that, because this is on the arrow, plus this plus that cell has to equal that. So if this was 6, 7, 8, and that was lower than 6, 7, 8, how would that work? So I can never put 9 here. 9 has to be in one of those two, because I can't put 9 here, because 9 plus something would mean this would have to be larger than 9. So 9 is in one of those two, which means 9 is in one of those two. And the same logic can be done here. I can't put 9 here, because these would be 6, 7, 8. These would be 6, 7, 8, 9, and that couldn't be higher than that, because these would be 1, 2, 3, 4, 5. This would be lower than that, and it doesn't work. 9 can't be here. 9 is in one of those two, which puts 9 in one of those two. I don't know that that helps me much, but it is an interesting piece of logic I remember that we found. No. I remember the logic that we wanted to use now. There is a couple of interesting pencil marks we can make on this Renban, but we must have another 1, 2, or 3 on this arrow. So, because there must be 2 of 1, 2, and 3 on each arrow. So I can't put 1, 2, or 3 into any of those cells there, because if I did, this arrow would have these cells would be a minimum of 4, 5, and these would sum to a minimum of 10, which I can't do. So there's no 1, 2, or 3 in here, and there's no 1, 2, or 3 in those. So I've got a 1, 2, 3 here, but I must put at least there's 2, 1, 2, or 3 in those cells, which means at least one of those cells must be a 1, a 2, or a 3. So there must be, the highest digit I could put in here is a 3. It could be a 1, it could be a 2, but there must be at least a 3 in here, which means the minimum this, or the maximum this line could be is 3, 4, 5, 6. So this is from 1, 2, 3, 4, 5, 6. This line cannot have anything higher than a 6 on it, because if it did, there'd be no 1, 2, or 3 down here, and I couldn't put 1, 2, 3 into any of those cells, and those two cells would need to contain 1, 2, 3. Now this can't be a 6 because of the 6, 7, 8, 9 quadruple. And now we can ask ourselves the question, where do 7, 8, and 9 go in box 6? Because I can't put 7, 8, 9 in any of those cells. I can't put 7, 8, 9 into any of those cells, and that can't be a 7, 8, 9. This becomes a 7, 8, 9 triple. There's no 6 there. These are 7, 8, 9. But that's a 6, 7, 8 triple with the 6 in one of those two, which means 6 is one of red or yellow, not orange, which means one of these is where the 1 goes. So 1 is either in here or in here, which means if this is the 6, this is the double 1. If this is the 6, this is the double 1. Neither of those cells can take a 1, because the 1s must exist somewhere in those cells in column 4 and column 6. Okay. Now, trying to remember what's next. Is it this? Because 4, 3, 2, I can never put 1 on this. 2, 3, 4, 5, 6. That could maybe go higher, but this is 2, 3, 4, 5, 6. Because I can't go higher than 6 on the arrow, and I can't go lower than 2, because 4, 3, 2. But this could go, or no, this actually is from 2, 3, 4, 5, 6 as well. And it can't be 6. This is only 2, 3, 4, 5, because I can't use 6, 7, 8, or 9, and I can't go down to 1 because 2 is as low as I can go on this Renban. Oh, 6, 7, 8, 9. That is a low digit, 1, 2, 3, or 4. So this is a low digit, 1, 2, or 3. These are high digits, 6, 7, 8, 9. I can't put 6 on in the middle of 2 digits, and I can't put 9 at the end of an arrow. So this is a 7 or 8. So this is a 1 or 2, and this is an 8 or a 9. The 1 or 2 means that's a low digit, that's a 1, 2, or 3. I now have a 1, 2, 3 triple in that row. There's no 1, 2, 3 here because there's 2 of them there and 1 there. This is a 4, 5, or 6. Now, I think there's a problem with that being a 3. Because if this is a 3, this is an 8, which means that's a 7, that's a 6. But if this is a 3, this becomes an 8. This is a 7, this is a 6. This being a 6 makes both of those 1s, but this is a 3 means this is 1, 2, which makes that a 6. So if this is a 3, we end up with 8, 7, 6, 1, 2, and that has to be a 6 to make the 9 arrow work, and we end up with both of those being 6s. So if that's a 3, both of those are 6s. That's not the 3, that's the 3, which means that's the 8, which means there's no 8 in either of those. There's no 8 here, and there's an 8 in one of those. And now I can get rid of the yellow colouring, the red colouring, and the orange, or the colouring in those cells as well. Okay, which means there's no 8 in either of those. That's just a 7-9 pair. There's no 8 there because these can't repeat. The 3 means that this can't be 1, 3, 5 or 2, 3, 4. This is a 1, 2, 6 arrow, and there must be a 6 in one of those two, which means there's no 6 there. In fact, these are 4, 5, 8. This is also 4, 5, 8. The 6 is now in one of those two. If I put 6 here, these become 1, 2. Because it'd be 6, these would be 5, 4, 3, 6, 3. It'd be 6. These would be 4, 5, 3, 1, 2. And that doesn't work. This can't be a 6. Because if this is a 6, these would be 3, 4, 5. These would be 3, 4, 5. There'd be a 4, 5 pair there. So that would be the 3. These would be 1, 2. But those would be 1, 2, which means that would have to be a 6. And this is part of the real trick with this puzzle, is understanding how these 3-cell 9 arrows work. So if that's a 6, that's a 6. So that's not the 6. This is the 6, which means this is a 1, 2. So there's no 1, 2 there. So these are both 1, 2, 6. There's no 6 here because of these having to sum to 6. They're 1, 5 or 2, 4. I wish I remembered the trick. So I've got 1, 2, 3 not in those. It's not there. So 1, 2, 3 is in one of those two, and I don't think it can go there because it'd have to be 1, 2. So I can't put 1 here because then I'd have to put 2 on this arrow because the 3 would go here. Because if I put 1 here, these would be 1, 2, 3, 4. The 1 would be here. The 3 would have to go here because 3 is in the box. And then I'd have to put 2 here and I'd have 4 of 1, 2, 3, 4. But I don't think it could be 2 either. Because if it's 2, the 3 would go here and these would be 4, 5. These would then be 6, 7, 8, 9. And this can't be 6, 7, 8 or 9 because 6, 7, 8 and 9. So I can't make this 1 or 2. So where is the 1 or 2? I can't put it on this line. Well, I can't put it there because 1, 2, 3 triple. I can't put it in any of those because of the 1, 2, 3 triple. So it's in one of those two and I can't put it there without breaking the Renban. This is the 1, 2. I do remember finding that. That's an interesting trick. So 1, 2, 3, 4, 5, 6 or 7, and it can't be 6 or 7. This is only a 4 or a 5. So 4, 5, 6, 7. So I can't put an 8 or a 9 on this Renban. Because 5, 6, 7, 8, I can. I could put an 8 on the Renban. I could see 1 is in one of those two. Because I can't put 1 there. Why can't I put 1 there? Why did I take 1 out of there? Why did I take 1 out of there? Why can't that be 1? Was that a typo? No, it's not. It's because 1 has to be in one of those or one of those. 1 must be in one of those two. Okay. So, let's colour the 1s and 2s. So we can use purple, dark green, whichever one this is a different one. So this is back to the same one. So this would be dark green. This would be dark green because it's different to purple. This would be purple because it's different to dark green. And this cell here sees both dark green and purple. So that's the 6. This is not the 6. This is the dark green 1, 2. So this is the purple 1, 2. There must be a 1 or a 2 on this line. So this could never be a 5. 2, 3, 4. The maximum this could be is 4. So this is a 4, which means this could never be a 1. So this is 2. So dark green is always 2 and purple is always 1. So I can now get rid of the purple colouring and the dark green colouring. The 1 comes out of here. This is the 2, 3, 4 arrow. This is the 1. There's no 1 here. There's no 2 here. I'm close to getting rid of the blue. 1, 2, 6. 1 and 3 is 4. So this is the 5. 1, 2, 6, 2, 3, 4. I think it's now time for me to get rid of. There's no 1 here because of this. I think it's now time for me to get rid of the colouring completely because I wanted to, the arrows are now resolved and that was the trick I was using them for. To connect the 2 and the 4 on the Renban, this becomes the 3. So there's no 3 here. This isn't a 9, so that's never been a 4. So this is now the 1. The 3 looks across taking 3 out of here. So 3 in this box has to be in one of those cells. This is the 3. 3, 4, 5, 6, yeah, maybe, but there's no 3 here. The 4 takes 4 out of both of those. That's a 5, 8 pair, which looks down, making that a 4. The 2 means that can't be the 6. That's the 7. The 6, which means this is the 6. Now, we know the 7 can't go next to a 3. It's too close. So that's the 2, that's the 3, which means that's the 2, which means that can't be a 6 because a 6 can't go next to anything but a 1. This is 2, 4, or 5, and there must be a 2 in it for the 2, 4, 5 triple. So this is a 4, 5 because it's a 2, 4, 5 triple in the row, but it can't be the 2 for multiple reasons. 7 is in one of those 2 for this box. This is either 7, 8 or 8, 9. So what are these digits? 5, 6, 8, 9. 4, 5, 6, 7. I can never put 8 or 9 on this line. This is a 5, 6 pair, so this is an 8, 9 pair. The 5-6 pair, the 5 looks down, making that the 6 and that the 5. So this is a 3 or a 7. In order for the Renban to work, the 3 looks down, making that the 7. 6 is, this is either a 2 or a 3, and the 2 means that's the 3, making that the 9 and that the 8, which takes 8 out of there. The 6 looks up, making that the 7 and that the 6. This column is missing its 4, so this is a 7, 8, 9. But there's a 2 difference, so that is 7 and 9, and that's the 8. There's no 7 there. The 7 means that can't be a 3, there'd only be a 4 difference. That's the 1. And I know I've complained many times in the past about puzzles that resolve to where these are the solved digits in the grid, and then you've got to do Sudoku to work into the corners. But this is a harder puzzle. Yeah, this is a harder puzzle. Okay. There are elements to this puzzle I'm not a fan of. But, you know, hopefully you enjoy it. I mean, I do enjoy this puzzle. There's no 6 here. So this is either 1, 2, 3, 4 or 2, 3, 4, 5. So 2 and 4 must appear in here. So I can never put 2 or 4 down here. So 2 is in one of those 2 cells. 4 is in one of those. 6 and 6 can't be in any of those. That is a 6. So 4 is in one of those cells. 3 is in one of those cells. 1 is over here. Okay. These are 4, 5, 8, 9. Well, where's 5 in this? This is 4, 5 because I can't put 4. 4 has to be here because I can't put 4 in any of those. So 4 is in here, and in this column 5 has to go here because 5 can't go here. This is a 4, 5 pair. So this is 8, 9, and the 9 makes that the 8, that the 9. 9 is 1 plus 8, which makes that the 5 and that the 8. This is now the 7. There's no 8 here. This is a 4, 5 pair. So these are 3, 7, and no, they're not. The 7 makes that the 9, and these are 3 and 8, and the 8 looks down, making that the 3 and that the 8. I nearly made a boo-boo. I hope I haven't. These are 1, 2, 9. There's no 1 there, and there's no 2 there. And the reason there's no 2 there is because 2 and 4 must appear on that line. These are 4, 5, and 7. And again, there's no 4 there because 4 must appear on that line. What can this be? 4 plus 3 equals 7. 4 plus 5 equals 9. It can't be that. 5 plus 3... No, 5 plus 4 equals 9. Or 5 plus 2 equals 7. Okay. 3 is in one of those 2. 1 is in one of those 2. Three is right there. 3, 3, 3 is up here. I can't put 3 next to 1, and that 3 is saying not there. That's a 3, which takes 3 out of there, making that the 3. This is only 2 or 4 now. 4, 2, 6 doesn't work. 4, 4, 8 doesn't work. This is a 5, which means there's no 5 in either of those. The 2, 4 looks across, making that the 5 and that the 4. 5 looks down, making that the 7, taking 7 out of there. 5 on the line means this line is 5, 4, 3, 2. There's no 1 on the line. That's the 1, taking 1 out of there. This is a 2, 9, making that the 1. This is a triple. Actually, let's do this pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 4 and 9. So that's the 4, that's the 9. 1, 2, 3, 4, 5, 6, 7 go into those. The 5, 6 makes that the 7. I take 7 out of those. I'm close to having solved it. This is a triple. 1, 2, 3, 4, 5, 6, 8, and 9 go in. There's no 9 there. There's no 8 there. There's no 9 there. So the 6, 8 pair makes that the 9. So this row is 1, 2, 3, 4, 5, 6, 7. So these are 5, 6, 7, must contain a 7. There's no 6 there. One, two, three, four, five, six. These are 4, 5, 6, 8. There's no 6 or 8 there. So the 4, 5 pair means that's not 4, 5. This is a 6, 8. Hang on, is this broken? No, there's a 2, 4 pair. So that's the 5, that's the 4, that's the 5, that's the 4. The 5 says that there's no 5 there. 2, 4. Where's 8 in this column? No, the 2, 4 makes that the 9 and that the 2. The 9 looks up making that the 7 and that the 9. 5 or 9 minus 5 is 4, or 5 plus 4 is 9, which makes that the 2, that the 4, and that the 2. So this is a 5, 7 pair now, isn't it? 1, 2, 3, 4, 5. Yeah, this is a 5, 7 pair, but that can't be the 7. So 5, 7, 6, 8, which looks down making that the 6 and that the 8. And the 6 looks across making that the 5 and that the 6. And that is the solution to bleeding edge. The stuff around these arrows is really tricky, and understanding how these 3 cell 9 arrows work with these whispers, so forcing these to be low, and then the properties of these having to be 5 different, and then the way that these low digits will always propagate because you need to have 2 low digits and the possible options on those low digits, and the way that the low digits are forced into particular locations in boxes, and the way the Renbans are forced and everything. There are chains in this, which I'm not often a fan of, but this is a harder puzzle. Now, I don't think this is a 3-star puzzle. I really don't. But Logic Masters Germany does. I'm interested in what people think the comments mean that this is. I really am. I'm really interested in knowing what people think. I hope you enjoy the puzzle. I hope if you get stuck, my solve guide is enough to help you get through it. And I'm sure Maggie is going to be interested in seeing what people think as well. But just because I'm posting one of my own puzzles, I'm interested in criticism. I do not mind if people don't like the puzzle, or if people think that there are problems, or if you've got specific issues and you wish to call them out. Call them out. Don't just say, if someone is just like, oh, I hated it, you're allowed to say that, that's fine. But what I'm interested in is specifics. People are allowed to have opinions of puzzles. You may hurt my feelings, but that's part of doing what we do. Not everyone is going to like everything you create. But to people, the ability to provide constructive criticism or to call out specific elements about things so that setters can then look at what people are saying and turn around and reflect on that and turn around and say, is this something I want to change or not? As I said, there are elements about this I think should be criticized. But that doesn't mean that, there are elements to this puzzle that I really wanted to share with people. I've heard a lot of people say things along the lines of, I'm bored with Renban, Arrow, Whisper, all of these constraints because there's nothing new in them. While Maggie and I were exploring this puzzle, we were blown away by the new things we found while doing this puzzle. I'm very curious to see whether other people are just like, oh, I've seen all of this before. I don't know. And if you have seen it all before, could you knock this out in 15 minutes? I'm really curious to see how that goes. Thanks everyone for watching. I'm really interested in seeing what people say. And as always, Good luck with your solving.